So far, most circuits were drawn from the inside. Every resistor, capacitor, inductor, op-amp, and connection. Now we change the viewpoint. A complicated circuit can be treated as a two-port block, one input port, one output port, and a small set of measured parameters. A two-port has four terminal variables, voltage and current at port 1 and voltage and current at port 2. The standard convention is that both currents enter the network. This may feel a little strange at the output port, but it makes the equations symmetric and reusable. The first description is the Z-parameter model. It writes port voltages as functions of port currents. The diagonal terms are driving point impedances. The off-diagonal terms are transfer impedances. Every Z value has the unit ohm. To measure Z parameters, use open circuit tests. If port 2 is open, its current is 0, so Z11 and Z21 come directly from voltage divided by the driven current. If port 1 is open, its current is 0, so Z12 and Z22 are found the same way from the other side. The second description is the Y-parameter model. It writes port currents as functions of port voltages. The diagonal terms are driving point admittances, and the off-diagonal terms are transfer admittances. Every Y value has the unit Siemens. To measure Y parameters, use short circuit tests. If port 2 is shorted, its voltage is 0, so Y11 and Y21 are obtained by driving port 1. If port 1 is shorted, its voltage is 0, so Y12 and Y22 are obtained by driving port 2. Which model should you choose? Use Z when open circuit tests are natural, or when series behavior and impedances are easier to see. Use Y when short circuit tests are natural, or when shunt behavior and nodal equations are easier. The model is a tool, not a religion. Two quick checks help catch mistakes. For a reciprocal passive network, the transfer parameters match. Z12 equals Z21 and Y12 equals Y21. For a symmetric network, the two driving point parameters match. Z11 equals Z22 and Y11 equals Y22. The workflow is simple. Draw or simulate the circuit, choose the port convention, run the required open or short tests, fill the matrix, and then use the matrix instead of redrawing the inside every time. That is why two-port models are so useful in amplifiers, filters, transmission lines, and cascaded stages. Summary. A two-port block replaces internal complexity with port variables and a parameter matrix. Z parameters use currents to predict voltages and are measured with open circuits. Y parameters use voltages to predict currents and are measured with short circuits. Next, we can extend this view to hybrid and ABCD parameters where cascaded stages become much easier.